Hey, greetings and welcome. Looks like we're recording here. We're going over last night's quest. We were talking about parallel lines. We were actually proving lines parallel based on facts we were able to determine from the angles. The theorems we had, which they are theorems, were all converses of the original theorems. So we had alternate interior angle converse. And a converse, like I just said, is a type of theorem. It is a theorem. It's just the converse of another one. So instead of giving it its own name, they call it the converse. Right. So let's jump into these. It says, find the value of x that makes m parallel to n. Now, what types of angles are these in terms of one another? Yeah, they're alternate interior. And if alternate interior angles were congruent, then by the alternate interior angles converse, we'd be able to prove the lines are parallel. So these lines will only be parallel when those angles are congruent, and if those angles are congruent, then their measures would be equal. So that's all the logic. Let's get into the algebra. No, I'm actually going to put an equal 3x over here just because I like my variables to end up on the side. So let's bring our x's to the same side. Oh, wow, this was like a very short algebra problem. X equals 20, right? Wow, okay. Wow, all right. And we didn't need to find the angle measure, but we could. It looks like this would have been 60 degrees. So there you go, friend. And by alternate interior angles converse, we would have been able to show that the lines were parallel. All right, I like these ones. Do you guys like these ones? These ones get you thinking. Decide whether there is enough information to prove that m is parallel to n. All right. Yeah, I skipped around. Yeah, I changed the order on my screen compared to your guys' packet. How about, so 14 here. What types of angles are those? And then by the converse, yeah, if those are congruent, then these lines are parallel. Okay, so that works out. All right, ooh, how about this 15 one? Yeah, like you could imagine if I redrew this, if this was like, I don't know, 120 degrees and this was 120 degrees, like those lines are just like not, actually that's not even close to scale. What am I doing? What am I doing? Ugh, gross. Guys, that was a sad moment in my life. Yeah, it'd have to be like this almost. Yeah, those lines are just like not going to be parallel. Is there a particular angle measure in which you predict they would be parallel? Okay, if this angle was over here and congruent, then by corresponding angles converse, agreed. So what would this angle measure have to be in order for both of these to be congruent? Yeah, so if these were both 90, then we'd be able to prove parallelity. But because that's such a unique case, and we wanted to prove this in general, we would just say no, because, yeah, there's just no relationship between those, and the majority of time it's just not going to work out. All right, how about 17? Yeah, for m parallel to n. I mean, vertical angles are always congruent, and n could just be like any old crazy line. Like, there's nothing restricting n, so just no. We don't know a relationship between those corresponding intersections. So no, I don't know, those were kind of my words. I'm leaving it at that. Words happened. No. Okay. Ooh, 24. All right, here's another 4 intersection set up here. It says, are AC and DF parallel? Explain. All right, so AC, DF. Now, I've got this congruent to that. So what does that tell me? That would tell me that, yeah, these two lines are parallel. By which theorem? Right, corresponding angles converse would say that these lines are parallel. That doesn't tell me anything about the lines that I'm looking for. All right, so if those are parallel, those are congruent. Does that actually parallelity help me at all? Well, using linear pair postulate, I could figure out from this to this. I don't think this parallelity actually helped me any, but it was true, just not helpful, which is fine. What would this angle measure be if this is 65? 115. Okay, here we go. And if that's 115 and this is 115, those are what types of angles? Also correspond. Man, we sound so enthusiastic today. I love it. Bam. Yes, the statement was when we're trying to prove lines parallel, we use the converse instead of the theorem. Yes, and if we know the lines are parallel and we're proving something about angles, that's when we would use the theorems. Yeah. Corresponding angle? We're proving lines parallel. Oh, corresponding angles converse. Yeah. All right, I don't think I gave you guys question 35 last night, did I? I didn't. But future generations of geometricians that take my classes will likely experience this problem. And so, actually, did you guys have a back page with any space to fit this one? Maybe not. Don't worry. You can just follow along then. So this is, I really, really like this problem. This is going to be, as you can see, we've got some triangles, and we are going to spend days talking about triangles. And so this is going to be good. And so I just wanted us to get thinking in that direction. And it says, write a proof. So let's see, given, I'll set up my proof. So you guys can just follow along. I've got my statements and my reasons. Let's start with my gimmies. So angle 1 is congruent to angle 2. I'll label that. All right, bam, bam. Given is y, it's true. And I know that angle 3 is congruent to angle 4. Now I'm kind of like hesitant in my even labeling this that way, but we'll see what happens here. That's also given. What's another thing that we could say, perhaps, that might help us? Yeah. Y is 2 congruent to 3. Do we have agreement on that? Vertical angles theorem. So... No, they are. They're triangles. They're for real. All right, so 2 is congruent to 3 by vertical angles theorem. Maybe my screen is, like, warped. That could be the possibility as well. Yeah. So 2 is congruent to 3. What's another statement? That doesn't help me prove lines parallel yet, but what's... 1 to 2, 2 to 3, so 1 to 3. And then 3 to 4. So it's a train of transitivity. 1 to 2, and 2 to 3, and 3 to 4. And the engine is congruent to the caboose. Oh boy. A train of transitivity. 1 is congruent to angle 4 by the transitive property of congruence, technically. Congruent angles, even if you wanted to be so specific. Angle 1 congruent to angle 4. How does that help me? Oh, the types of those angles are alternate interior with respect to this line and this line cut by said transversal. And so I can prove that, man, you guys, well, one of you's talking. I'm assuming more of us are hopefully at least recognizing what's going on here. Recognize this. So AB is parallel to CD by the alternate interior angles converse. Converse. Well done. Well done. All right, thanks for watching, Internet friends. Have a great day.